Now we are going to discuss the next topic, that is perpendicular distance from a point outside a plane to the plane. That is, we have to find the perpendicular distance of a point which is not lie in that plane, that is outside to the given plane. Let pi is r dot n is equal to d be the equation of a given plane, and as we mentioned, we have to find the perpendicular distance of a point lying outside from the plane. So let point P with coordinate P be a given point that is P does not belong to pi plane. So let we draw the diagram. This is the plane pi, and as it is a plane, so it has a normal. So let n be its normal. Now here suppose P is the point with direction component P, and let if we draw M with coordinate M is the foot of perpendicular from point P with coordinate P to the plane pi, that is we take from P a perpendicular to the plane at M. Then we can find the distance PM, as we can see in the figure. Direction of MP and normal N are same. Therefore, the equation of MP will be vector R passing through point A having direction N, that is the equation of line MP for K belong to R, as point M with direction component M lying on MP, that is it becomes for K1 vector M is equal to vector P plus K1 times vector N for K1 belong to R. That is M is also belongs to pi. Therefore, M also lie on the plane, that is M dot N is equal to D. So, we can say by substituting here value of M, it becomes P plus K1N dot vector N is equal to D. It gives P dot N plus K1 N dot N is equal to D. So it gives K1 dot n is modulus n square as angle between n and n is 0. So cos 0 is 1. So it becomes K1 dot n1 modulus square is equal to D minus P dot n. So from here we get K1 is equal to D minus P dot n over modulus n square, as this is the value of K1. As if we see Pm is equal to modulus of Pm position vector, that is magnitude of this. So it will give m minus p position vector of Pm and then taking the modulus, as m minus p is from the equation vector m is equal to p plus k1m is k1n vector, that is modulus k1 modulus n. So value of k1 is, as we get from above, that is d minus p dot n modulus, that is a positive value, over modulus n square into modulus n, magnitude n. It gives Pm is equal to d minus p dot n over modulus n. That is a required perpendicular distance of a point from the plane. That is required distance that we are finding. So this is the way how can we find out the required distance of a point from the plane. Now we will find out Cartesian form of perpendicular distance of a point from the plane. So for this we will take Cartesian component of different quantity that is used in to find out perpendicular distance of a point from the plane in vector form. So let point P with component from where we have to find the perpendicular distance be the given point, and given plane is AX plus BY plus CZ is equal to D, be the given plane in Cartesian form. So here a vector n is component with A, B, C. Now perpendicular distance from point P to plane pi is given as D minus Pn is that is, we can write ax1 plus by1 plus cz1 minus d by taking the advantage of modulus sign over under root a square plus b square plus c square. Now we will do a problem based on this. Problem is that find the perpendicular distance from -1 to -2 to the plane (3x minus 4y plus 2z plus 44) is equal to 0. Now the solution is point P is -1, 2 and -2. Pi is 3x minus 4y plus 2z is equal to -44. That is D is equal to -44. And vector n is 3, -4 and 2. That is perpendicular distance of P from plane pi is ax1 minus 3, that is -8 minus 4 minus d minus minus plus 44 over under root a square plus b square plus c square, that is 9 plus 16 plus 4. So it gives modulus 29 over under root 29. So from here we get under root 29. So that is a required perpendicular distance from -1 to -2 to the plane 3x minus 4y plus 2z plus 44 is equal to 0.